Good afternoon, everyone. I'm really excited today. We have Rolf Witzsche and also Trevor from Suspicious Observers. Rolf runs the Ice Age of the Dimming Sun in 30 Years channel on YouTube. You can also see his website, Ice Age Ahead, IAA.ca. And today we wanted to talk about solar wind, indoor agriculture, cosmic ray formations, and a lot of other subjects. And I think you're gonna have a great time listening. And you know my channel, I run out the timeline of the cooling events through this next solar cycle to 2030, whereas Rolf was gonna bring us out into 2050, 2060 and beyond, so we can get a good gauge of how our global weather and global temperatures are gonna go from this point forward. So without any further ado, Rolf, I'll let you introduce yourself and yeah, sit back and enjoy. I think you're gonna learn a lot when you hear this conversation between the three of us.
I have been working for this project for about, for the Ice Age project for about 5 to 7 years, somewhere around there. Specifically, I've been making a whole bunch of videos, and most likely your viewer will have seen many of them. They're about over 100 on YouTube. So, but I'm more concerned about the impact of the Ice Age on humanity because of the impact of the Ice Age on our food supply. Without food, we don't live. Food is one of the most important things. And when you hear about Ice Age and fields of ice covering the landscape, you get kind of scared and you think, oh my God, that's Armageddon, that's the end of the world. We need our food supply. Fortunately, that's not the case because we're human beings and we have the capacity to look ahead into the future, determine how it's moving, understand the principles, and from that determine how we can react in the present to respond to the needs of the future. And that's what I really have been concerned about, to set a basis for us to respond in the present to the needs of the future. So we'll take it from there.
Rolf, now, if I could jump in, one of the most interesting videos that you put out that had enormous traction in YouTube was about Ice Age 45% complete. That's one of the things I wanted to talk to you about is the solar primer field and all these ideas that you had going forward. Can you explain that to us a little bit more? And Trevor, feel free to jump in with some of the questions because I know you are both experts on this idea here.
Well, first of all, I want to say something about the solar wind and the solar cycles and the solar coronal holes. We hear a lot about the solar wind getting weaker and its effect on our weather. Well, the solar wind really has very little effect on our weather. And then we hear a lot about the solar cycles getting weaker. Well, actually, the solar cycles themselves have very little effect on our weather either. The effect, the weakening solar wind and the weakening solar cycles are all symptoms of an underlying weakening of the sun itself, of its activity, of the strength of its being powered. And once the sun gets weaker, the plasmasphere around the sun that makes it go gets weaker also. And when it gets weaker, cosmic ray flux makes it through the protective shield that is around the sun that actually powers it. And when that gets weaker, we get more cosmic ray flux coming from the sun, and that's had a big effect on our weather. But it's hardly ever talked about because you can't see it. Cosmic ray flux just happens, and there's well, we have a few tools to measure it, but it doesn't really get much attention. But this is what causes our changes in weather. For the last, God knows for how long, the sun really has been steady, has been running at 5,800 degrees Kelvin. So it's been steady. So what's the talk about the sun getting weaker if its surface temperature doesn't change? Well, it is getting weaker, and we see the difference by the increasing solar cosmic ray flux that makes it through its protective layer. Once the solar cosmic ray flux hits our atmosphere, it helps to ionize the particles in the outer atmosphere. And when it ionizes the atmosphere, it enables a greater degree of water vapor nucleation that forms little clouds, and the clouds get bigger and form clouds, and eventually they rain out. If we have a lot of interference in the cloud cycle of the Earth from the cosmic ray flux, we get floods. We get increased cloudiness. Now, the thing with increased cloudiness is it's white on top. If whoever flew across the Atlantic will find, looking down, you see nothing but white. That's the white of the clouds, and the white reflects sunlight back into space. That's the energy, the solar energy that we lose, that we don't get coming down to the Earth, that makes the Earth colder. And that's what brings us gradually, slowly into a little ice age. Now, I predict that we are in a little ice age in around the 2030s because of the weakening of the sun and the increased cosmic ray flux. The sun will still be at 5,800 degrees Kelvin at that time, but the solar wind will have died down. The solar wind reflects a kind of safety valve, so to speak. When there's a lot of plasma pressure under the sun, some of it gets vented, and it gets vented so the top of the confinement dome of the primal fields that actually cause the solar reactions. It's too much for right now, but the solar wind is like the steam of a kettle. If you have too much heat going into the kettle, you have a lot of steam going out. The water doesn't get any hotter, but there's a lot of steam going out. But if you turn the heat down, the steam gets weaker. If you turn it down even more, the steam stops. And that's the point when the solar wind stops. It's just like the steam of the kettle. And then that's when you would want to watch out, because if the sun gets weaker still, then you will see a reduction in the solar surface temperature. And that point I expect to be around the 2030s. Now, from where we are today, to this point, we will see a weakening of the sunspot cycles. But these are only indicators that the sun is getting weaker. They don't really affect us too much. They have small minor effects, but really they're just indicators that the sun is getting weaker. And another set of indicators that the sun is getting weaker is the opening up of the coronal holes, the solar coronal holes. A hole in the corona in the sun is a weak part, and the plasma corona around it. If it's weak, there is not enough, well, how you should say it, atomic material in that region where the cosmic ray flux flows through. So it doesn't emit so much light. That means that area is weaker. And if you have a weak area around the sun, more cosmic rays come out through this weakened spot. Now that increased cosmic ray, if it's very dramatic, can cause floods on the Earth, because then we have a large increase in cloud nucleation. I've talked to some people. One fellow said that he'd been camping and they were setting up tent, and it was beautiful blue sky. Then all of a sudden it started to cloud over. In a very short time, it just was pouring out, just flooding the whole place. Well, this is caused by a sudden burst of cosmic ray flux, and it most likely was caused by a large hole in the solar corona.
Trevor, I know you wanted to talk about the different layers of the sun here. You want to take that point?
Mm-hmm.
Yeah, that's something I can take and run with. Basically, in 2015, we had a paper produced that showed in between the outer layer and the inner layer of the corona, we're seeing oscillations that are taking place that can be used to forecast a longer range speculation, more or less, on the output. So we're seeing a decrease in the solar sunspot that are basically taking place up to 2030, like Rolf said, a continuation in a decline in sunspots. And I believe Rolf's got it right on the money here. It's a shrinking heliosphere. That's what we're seeing. The outer planets like Pluto, Uranus, Neptune are all manifesting changes, including Saturn, that are a lot more intense than what's taking place on the inner planets. And these intense changes are indicating exactly what Rolf's saying here. The heliosphere is shrinking, more cosmic rays are penetrating, and we're seeing dramatic climate change due to the cosmic rays, more so than the influence of the solar wind.
Can I add something to that? Referring to the solar coronal holes, that's a fairly new phenomenon. Around 2005 or 6, 7, that time frame, it made headlines when a little coronal hole appeared. Now you can see a coronal hole that covers almost the entire face of the sun, and it doesn't cause any concern. It doesn't cause any raised eyebrows. Well, some websites monitor that, and STO reports that almost every 15 minutes or something like that, or even faster. But this is really our frontline indicator. The more and more we see of this, means the weaker and weaker the solar corona gets and the sun gets. And that's something you can actually see. It's quite dramatic.
Yes, it's the observable evidence. I mean, we know with the coronal holes that during the sunspot cycle and these solar cycles of 11 years, these coronal holes are normally at the polar regions, the south and north poles, and they migrate towards the equatorial region during solar max. But they are acting very unusual in that the north region's not stabilizing. The south region shows some stabilization, but it's still wandering a little bit. But the North Pole is very erratic. And when we look at the strength of these fields It indicates when our solar max is reaching its midpoint. This is part of the cycle with these coronal holes. And what we're seeing seems to be, like Rolf's indicating, you know, these holes are not stabilizing. We know from earthquake predictions, forecasting that we're doing, the coronal holes play a major role in this Alvin wave emission that takes place and disrupts layers in our ionosphere. There's an impact, and there's planetary alignments, and the coronal holes come together. We have these solar sector boundary crossings as well as these co-interactive regions that really help to pin down an algorithm that we've been successful in using to predict these earthquakes. So
yeah, you did an amazing job predicting the earthquakes and linking them to especially solar mass ejections. But one thing is also, if you have the coronal holes, there's also bursts of solar wind coming through, and there's all kinds of other stuff that's coming through that affects us. Probably some kind of plasma streams that are sort of reaching the Earth, because most of the earthquakes are electrically charged, caused by plasma coming in from the sun. And when it comes in waves, when it hits unprepared in a region that is just at the edge, it gets triggered. There's a lot of force in electric action. The electric force is, what is it, 39 orders of magnitude stronger than gravity. So you have a big push injected into the ground.
Yeah, that's what we're seeing. I mean, the energy is coming in from an outside source, affecting and disturbing the lower crustal regions, causing this electrical stress fracturing. You've done it very well in a video explaining this process, and I believe the increase in solar activity with a flare disrupts the equatorial current sheet. So even something on the backside of the sun, a large X-class flare coming off, can cause perturbations throughout the entire current sheet, affecting the Earth on this side. And that's what we see. Roughly 2.5 days from the eruption, we'll have some form of perturbation take place. And whether it actually materializes in an earthquake, it depends on several factors. But it is used as one method in this algorithm to forecast earthquakes, along with the planetary alignments, the coronal holes. We find that there's connection points, like you'd mentioned, Rolf. There's these flux tubes that seem to connect these planets to the star. And when we transgress these tubes in our orbital pattern, as the Earth does so frequently, we tend to have an earthquake at this period. But we also have earthquakes with the high and low points of the solar polar field reversal process. So in those high points in the high A stack and the troughs and the low points of solar activities, lulls and highs, we have our biggest earthquakes, 8s and above. So the solar polar fields play a major role in our largest earthquakes. And the stabilization of those coronal holes depend, on that consistency of the cycle. And we're not seeing consistency. We're seeing symptoms, like you're saying, that continue to manifest a problem. I really wish they had something to replace Ulysses. The mission was outstanding in gathering information. Could you go into a little bit more detail about this mission and what was discovered?
Well, the Ulysses mission was actually, it's my belief, it was primarily created so that we could look at the sun from outside the Helios, from outside the ecliptic. Most of our satellites operate around the sun, very close by, and the sun is in the ecliptic, and the ecliptic happens to be also the area where the heliospheric current sheet flows. So all the readings get a little distorted by the heliospheric current sheet. So they created a satellite that would take its instrumentation outside the ecliptic in an orbit, a polar orbit around the sun. And there it runs into sort of clean space. It gets nice clean measurements of the solar wind speed, and surprisingly, they discovered little fluctuation of the solar wind speed itself. But they did discover that the density of the solar wind has diminished during the 10 years in which, after the first, they made the first pass was sort of like establish a reference point, and the third pass going after that gave you a measurement of the diminishment of the solar wind. And that's a 30% drop which they measured. 30% in 10 years. That's an enormous change in cosmic time frames. And they also saw a 20% increase in solar cosmic ray flux. So that's almost, that's what one would expect. But you wouldn't expect the 30-degree diminishment. Now, I find it amazing that when you take the 30 degrees, 30% diminishment for 10 years and project it forward, well, we're running out of steam in the 2030s. We may still have a little wisp of solar wind, but the sun will be so weak by that time that we will probably see the solar surface temperature diminishing after that. And that's kind of a tripping point. I don't know what the conditions were during the little ice age in the 1600s. That was a time when they had no sunspots at all for about 30 years, or very, very, very few. So are we getting back into this? I would say we'll probably run out of sunspot cycles before we run out of solar wind speed. So I would say the 2025 will be no sunspots. I don't think so. And then after that, we get little ice age conditions. Little ice age conditions, they caused, the last time around, they caused widespread starvation around Europe in the order of around 10%, and in the northern regions, in the range of about 30%. So that's quite a starvation. But it doesn't have to happen to us. We can get prepared for it. We can create agriculture and put it into warmer areas where the cooling doesn't affect us. And that's long before the real ice age starts. What the time frame will be from the time the solar winds stop and the solar cycles stop until we get into the real deep ice age phase shift. It's hard to tell because we have nothing to go back for, any historic data. But I would say I would expect it in 10 years from the time the solar winds stop, and I hope it will be 30 years, because before humanity is ready to vacate the areas that become uninhabitable, we need to have an alternative area built up where they move to. And if that doesn't happen, we lose our food supply. That would be chaos. It'll be unimaginable. We can't let
Rolf,
it.
Rolf, can I jump in with a question quickly
Yeah,
here?
go ahead.
Talking about wavelength output of the sun, you know, different nanometer waves to grow different types of food on our planet. A lot of people have written me and talked about the sun being much whiter and a hot bite to it due to the UV increases. Now, going forward, do you think we'll see a color spectrum change in the sun, or what do you feel about that as we get further in the decrease of the output activity of the sun?
Yes, we see a shift of the black body curve, something like this, and the weaker it gets, it shifts towards the red, ever so slightly, but the area of the visible light, where the plants get their energy from, it's still within a fairly good range. So it's a little off-center, but not dramatically. Nevertheless, it will be shifted, but it will be of lower intensity too. However, I did some study, and actually it was somebody else that gave the information to me. The plants use very little of the actual solar energy. I read that somewhere in the order of 0.2% of the solar energy is actually used up in photosynthesis. And this energy that's absorbed is in two very narrow bands of light. So if we tune our artificial lighting to coincide in these narrow bands, we can perhaps artificially give the plants more light where they need it, and that would be only one watt per square meter. It's amazing. We can help them out with 1 watt per square meter if it's tuned correctly. And another way we can also increase plant production dramatically is by increasing the carbon dioxide concentration in the areas where the plants grow, in indoor facilities. Right now, greenhouse operators, when they increase the CO2 density, when they double it, they get a 50% increase in plant growth. I don't know what happens if they triple it or quadruple it. It may not be easily done because CO2 is deemed a poison. Nobody really dares to go very high on that. But I don't think we have seen the limit yet of what we can do to enhance agricultural production with increased CO2, with regulated temperature, with a little support, with extra lighting, and even without extra lighting, I think that the CO2 increase and the right fertilizer, the right watering, there's a lot of things you can do. I would think we probably get tenfold increase in plant growth. That makes a lot of difference to our food supply. If we put it out on afloat on the oceans right along the equator, then we get the maximum solar exposure. Even if the sun gets dimmer, that should compensate for a lot. Right now, the difference between the solar radiation on at the equator versus around 50 degrees latitude is about somewhere around 60 to 70%. That's quite a large difference. And we are able to grow wheat at the 50, well, no, maybe not quite the 50-degree latitude, but somewhere around there, fairly high up. If we can grow wheat up there, we can grow wheat at the equator under lower solar intensity, even without any enhancement. So I think we're in a fairly good position to say with certainty that we will not starve to death. We have the means to produce the food by responding to what we know about the future ice age conditions. Now, I have done some study on what might be the solar surface temperature when the primal fields fail. The primal fields are electromagnetic fields. They depend on flow volume. If the flow volume diminishes to the point that the primal fields can no longer form, then the plasma that powers the sun just sort of passes by like a default environment. And so I did some looking around what the temperature would be for a default environment. And I've seen a lower range of stars. They come in around 50 to 100 degrees, somewhere between 4,800 degrees, and ranging down to 4,000 degrees. When you get below 4,000 degrees, then we run into the so-called brown dwarfs. But there are also large brown dwarfs that are only 70% smaller than the sun. So our sun is actually a rather mediocre star. It's not another particularly bright one. It's not a particularly large one. It's sort of mediocre. They call it a yellow dwarf. And once you're having a star that's at the edge, if you drop it down a bit, I would say we can expect something in the order of 4,000 degrees. There are some large suns out there. They run around 3,200 degrees. I don't think we can get that low, but somewhere between 4,000 and 4,500 is probably what we will see. Yeah.
Yeah, Trevor, you want to go on with that? I know you were talking about that exact same thing earlier.
Yeah, I was mentioning the cold stars we had seen recently, and some articles pop up that are pretty low temperature, and it just brings to mind cold plasma, room temperature plasma, and just so many different possibilities and hypotheses with blue stars, blue spectrum stars, red spectrum stars, and yeah, what it end up being. I mean, is this a process of metamorphosis? Is our sun going to step down into something like Saturn eventually, possibly like a Jupiter, Neptune to a planet? Really brings to mind a lot of questions when you start saying that a star would change to a red giant or whatever. I'm not convinced that a star could actually change. I believe a red giant's created in that state, remains that state till it goes out. And if it does change, then we need to start discussing, stellar metamorphosis theory, because that brings into a lot of possibilities that the Earth could be the remnant core of a star. The isotope decay rates that we're seeing here on Earth and the composition of materials, I mean, it only makes sense that this is stellar material left over from possibly a star.
Oops, sorry, carry on.
Oh, no, I'm done. Go ahead, Rolf.
It all depends on what we understand the sun to be. The mainstream theory is that the sun is a sphere of hydrogen gas, and that the gravitational pressure compacts the gas to such high density that nuclear fusion occurs at the center, and that heats the sun from the inside out. That's a theory. That's a generally accepted theory. But when we look at the sunspots, you don't see anything bright inside. The sunspots are holes torn into the photosphere. And you look down into the lower layers, and behold, the lower layers are dark. Darker anyway, darker than the bright radiating surface. So we kind of disprove with this, what we see in the sunspots, that the sun actually is internally powered by a nuclear fusion reaction at its core. It makes sense. It makes a lot more sense to assume, or also to theorize, that the sun is not hydrogen gas, but is plasma. If you have a sphere of plasma, plasma is a soup of protons and electrons. Protons repel each other, and electrons are attracted to the protons. But they don't latch onto the protons, instead they dance around it. There's always motion between the protons and the electrons. But now we have a star that is made up of this soup of protons and electrons, but a massive star that has a substantial amount of gravity also. Now the electrons are 2,000 times lighter than the protons. Now if you have light, like if you put peas into a soup that are light, they kind of come to the surface. They migrate to the surface. And it is my theory that the gravitational pressure migrates the electrons in the soup, in the plasma soup, to the surface or to a specific layer. And that frees up the forces that keep the protons away from each other. With that gone, the protons inside of the sun have a lot more power to repel each other, because there are fewer electrons in between that get in their way. This makes the sun actually light enough to come in with the kind of mass density that we have measured for the sun. In my estimation, it's not possible for a sphere of hydrogen gas of the size of the sun to actually exist. It should be 1,000 times heavier. If you compare the mass density of Saturn with Jupiter, you have a double mass density in Jupiter compared to Saturn, but you also have a double volume of Jupiter versus Saturn. Now the sun has 1,000 times greater volume than Jupiter, but it has almost the same mass density as Jupiter. Something doesn't add up here. But if the sun was plasma, that is lighter on the inside and has its mass on the surface, then it makes a lot of sense what we see in terms of the overall mass density of the sun. That's one thing that goes against the sun as a hydrogen gas star. The other is the solar wind itself. The solar wind accelerates away from the sun at an increasing speed. Well, have you ever shot anything into the air? It always comes back down again. It doesn't accelerate away from the sun. So there are electric forces involved in accelerating the solar wind. And then we have the thing about the corona being actually hotter than the surface of the sun. How can the outside of the far away of the sun be hotter than the surface of the sun itself? In a plasma environment, that's possible. From a hydrogen gas environment, it's not possible. So we're, we're looking at a different kind of sun than what the mainstream science assumes it to be, because nothing really makes sense. And then we have this one large exception. We have this star UY2 Suti or something like that, a very large star that has a 5 billion times greater volume than our sun, but only 10 times the mass of our sun. How can a star that is 5 billion times larger in volume and has only 10 times larger mass create such an enormous pressure inside at its core that it sustains nuclear fusion reaction? It just doesn't add up. The only way such a star can actually operate is by being powered from the outside. And this star that is so thin that it runs only at 3,200 degrees, it outshines our sun 340,000 fold. It somehow it doesn't add up with the hydrogen sun theory. That once we get into this recognition that our theory about the sun needs updating, then a lot of things fall into place.
Yeah, I would agree. And I think we really need to go back to where this started with the three theories that were put forth: the nuclear furnace hydrogen model that we see so many issues with. There was also the electric sun model at that time that was being argued, as well as the liquid hydrogen metallic model. And the liquid hydrogen metallic here recently has been showing some very interesting developments with Pierre-Marie Robitaille's work, and some recent developments that are coming out of Asia with some tests with a spherical diamond with a void in the middle. They were able to form liquid metallic hydrogen within that concentration, which I find fascinating. But I think there's more to this. I think we had to take components from the liquid hydrogen metallic model as well as the nuclear fusion model to really understand the electric model that's still lacking. I think the terminology is lacking too. I think we need to start describing this as a plasmoid, because the characteristics of a plasmoid are the closest representation to that sun. And what Rolf's saying here, it's the only thing that really makes sense. There's an electric arc and a Zeeman point pinch at work here. And that energy is flowing in from an outside source. It's the Homer motor polar configuration of our galaxy here, the Milky Way. And it pours that current right into the equatorial current sheet, which is a very thin sheet at the equatorial region. The heliospheric current sheet of our solar system has just stepped up to a larger scale for the Milky Way. And we know that region is very concentrated with energy. When we have a solar sector boundary crossing and the phi angle shifts in the ACE telemetry, we see that energy pour into Earth with a southward BZ polarity, causing geomagnetic storms. So We really need to take a look at this current sheet because we're making associations with tornadoes, hurricanes ramping up. All this activity seems to really increase when we have a solar flare and then we have a solar sector boundary crossing. So it's always more intense when we're within that equatorial heliospheric current sheet than it is when we're outside receiving a flare. And I believe it's the same way on a larger scale with the Milky Way. There's more energy concentrated towards the center. And things like the Sagittarius A cloud that's very close to the Milky Way really makes me think, is this something that's taking place on a larger scale at the center of our Milky Way? Is it possible that that's just really a larger sun and that's a flare that came off? And the heliosphere is all the way around the entire Milky Way in this Homer motor polar configuration. And what we're actually seeing is just a larger star at the center, but it's so large that we're residing within the photosphere of it. So plasma is scalable. Oh, we can scale it up to larger sizes. Is that what we're seeing here, Rolf?
When you look at the graph that NASA has published for the results from the Ulysses mission, they created a circular graph instead of a flat graph going up and down. And the circular graph is representing the strength of the solar wind by the angular position against the sun. And the interesting part is over the North Pole and the South Pole, the Ulysses measured nothing. They reported a void. Now, if you have a plasma sun that is fed by primer fields that focus plasma onto the sun, that's where the plasma inflow would come in a very narrow band over the North Pole and flowing through over the South Pole. That matches what has been actually replicated in the laboratory and has been explored in details. So we do have a star that is fed by plasma from interstellar plasma streams. Now, the heliospheric current sheet itself most likely flows out from the sun. I don't know which direction this flows. I don't think we really know much about it. It looks like we have the same sort of configuration as Saturn with its rings around it, electrically focused set of rings around the equator of Saturn. And it's a very narrow band. It's only, I think it's just a few meters wide and hundreds of thousands of kilometers in extending outward from the Saturn. So we do have a lot of electric forces, and we also have the current heliospheric current sheet being probably something like, in principle, like the Saturn's rings. Now, the problem that I have with the electric sun theory that sees electricity flowing into the sun, and that it may be flowing out through the heliospheric current sheet. But if you pour in electricity into the sun, eventually the bucket gets full. You just keep pouring in and pouring in. But if you recognize the sun to be a plasma star fed by plasma, and in such a manner that the plasma combines and synthesizes atomic elements, After all, every atomic element that exists is a combination of electrons and protons. It's plasma bound up in an organized manner. And the thing is with atomic elements is that they are electrically neutral. So by synthesizing atomic elements, the sun acts like a sink to the inflowing plasma, and that enables a flow to happen. And this is what I don't see in the electric universe, in the electric sun theory. I see electricity flowing into the sun, but I don't see the sink effect anywhere that causes the flow. Yes,
completely.
Go ahead.
We tried to explain this with Markland convection as a possible hypothesis for our star water conclusions, but you have to see the sun as a producer of all these elements. We were seeing them come out of the sunspots, everything from gold, water, iron, all these heavy metals and stuff. It's obviously producing these elements, and how the energy becomes matter, mass, is still not explained by the electric universe theory. That's a major leap they haven't made yet either. And there's still a lot to figure out. Mm-hmm. How does energy become matter?
Well, if you look at the little granules on the surface of the sun, see them as a reaction cell for plasma flowing into it, being accelerated, and by being accelerated, becoming combined. And these are huge cells, probably somewhere in the order of 500 kilometers wide. We haven't got anything close to that kind of accelerator ever built in any laboratory that can accelerate plasma on such a vast scale and compress it that they actually form and synthesize atomic elements from the protons and electrons that flow around it. If you accelerate them fast enough, and they get caught up in magnetic fields, it's quite easily to see electrons and protons becoming bound up and forming atomic elements. And that's what we see. We see the sun surrounded by all the, well, I don't think all the known elements have been detected in the surface of the sun, but all the major elements have all been detected there. Why would they get there? How would they get there if they're not being produced on the sun? So the sun is an engine that synthesizes atomic elements.
Yeah, I agree with that completely.
Mm-hmm. Now, my problem is we're potentially 30 years away from a phase shift into the next ice age. Unless we get together somehow on a theory that can either substantiate or totally deny that potential possibility that the ice age starts in 30 years, we won't get the infrastructures developed to do it. That's the most critical thing that I come up with is how do we break the barrier in our mind against what is reality? And we know some of it is probably right, and this is probably right, but can we say with certainty, this has to be that way, and we can act on that assumption? If we gamble erroneously, if we say well, the plasma theory is way out there, and the ice age won't come for another 1,000 years. Then we will not do things. We won't stir our stumps, and when the ice age actually does happen, then oops, we don't have anything to eat. Goodbye, humanity. So we're gambling with enormous stakes here. And so how do we accelerate our scientific development, our own thinking to a point where we can agree that, yes, this is probably the way we go, and we must move on that assumption that that is right, because the stakes are so huge. If we don't move, we lose. But if we make an error by being too cautious and start developing our world towards a much more powerful agriculture than we have right now, and the ice age doesn't come, what have we lost? We got nothing. We lost nothing. We have a richer world to live in. But that all hinges on whether we'll do it, what is right, what is probable, what is perhaps, what's probable, what's not probable, and what can you prove, what you cannot prove. My perception is that the plasma universe theory is the only thing that offers sufficient degree of certainty in actual observable evidence to assume that we will have an ice age coming up fairly soon. It may not be in 30 years, it may be 35 years, or it may be sooner, but something is coming. And there's a lot of people that have actually said, well, we really should look into the possibility that we're hitting an ice age. Professor Dr. Jaworowski, for example, the chairman of the Scientific Council of the what is the Office for Radiological Protection in Warsaw, he advised the Congress, he advised the UN, saying, you should really look into this thing, because something could happen within the next 50 years, and he said something could happen so fast, it would only take a year to materialize. And he didn't have the knowledge that we have gained through all the space exploration and through ice core drillings. He did his own ice core explorations. He was going through glaciers on 6 continents, digging out ice cores, analyzing them. And after 50 years of doing that, his perception was, well, it could be 50 years, could be sooner, it could happen within a year and without warning. And that's exactly what we sort of see in in exploring the plasma star-sun theory. We can say everything with absolute certainty, but we see a lot of evidence emerging that agrees with what Dr. Jaworowski had said in his paper in 2003.
Yeah, now, Rolf, also, when you're talking about terrestrial changes here with the cosmic ray influx, so far 15% increase over the last 5 years, what happens if that turns into an exponential increase instead of, it's 5%, 15%, 20%? What if it goes to 50% in a matter of a year? What kind of cloud density will occur on the planet? How will that affect our agriculture with floods? And what are the other ramifications that you see if there is truly an increase that in an exponential fashion with the cosmic rays and the ionization and the creation of clouds planet-wide?
Well, we would definitely see an increase in cloudiness. the thing is, if you have a lot of cosmic reflux and it causes a lot of cloudiness, it rains out fast and it diminishes a little bit the water density on the Earth. So it's hard to know whether we're going to see an exponential increase in cloudiness. Probably not, because we have counteracting factors. The more the clouds rain out, the less dense is the water vapor in the air that the clouds are made of. So there is a balancing factor in there. But we probably see, I would say, 20, 30 times the amount of cosmic reflux hitting us. Now, they did a study a while ago, since we're talking about this, the increase in cosmic reflux may be beneficial to humanity, our cognitive processes, all our nerve system, our brain functions, they all operate electrically. Maybe, I have no evidence for that, but maybe increased cosmic reflux nourishes these processes. Right now, every one of us gets bombarded with about 50,000 cosmic ray events a day, and they go right through. But as they go right through, they do leave behind a little magnetic field that creates an electric current. So there's electric induction. Now, the study that I done, I looked at the cold periods over the last our interglacial period, and in all the cold periods, good things happen for us. The development of the written languages came during one of the deep cold periods, which typically have higher rates of cosmic ray flux. The Golden Renaissance was during a colder period. There's a bunch of these things happened at times of cold periods. And inversely, when the solar activity wrapped up, as we had it in the last 300 years from the Little Ice Age onward, we got into this nasty stuff, wars, nuclear wars, well, almost. I don't know if there's a connection, but it points to it that we benefit somehow from cosmic ray flux. After all, we grew up over the last 2 million years, which were all ice age environments, and with high rates of cosmic ray flux. And it may be the reason why we exist and talking today and are intelligent enough to see forward in the future is all because of the services that the cosmic ray flux may have given to us. It's a wild theory, but there is a possibility that something of that is true.
Yeah, I think there's something to that. We know from our studies that radiation damages DNA, but it also causes DNA to repair itself. So through the process of damaging and weakening our immune systems, we actually become stronger from that. And there's changes that are manifesting in our DNA and our conscience. And there's, I believe, focal points. Einstein, all the great minds came together after the Schroeder cat experiment to discuss this experiment and the effect of the observer. And there we must question, how much influence do we have as a global conscience? How much influence when we take a focal point like 9/11, and there were the minds of the world were focused on one event. Look how powerful that was. The random number generation that Princeton was working on was massively affected by that effect. And it just takes me back to that conversation that Einstein and all those great minds had sitting there. You know, how can we apply this and make sense of this when it's a variable that is affected by observation? are we observing the sun in a way now that's changing it? I mean, we're watching the sun like we've never watched it before. I mean, hundreds of thousands of people are now paying attention to solar activity because it affects our everyday life with electronics. I just question this, effect, the observer effect. How much effect do we have on the outcome? And if that be the case, then it only takes us creating a focal point to really concentrate everybody's attention on this. Is that what we need? Do we need some kind of focal point like 9/11 to really, get people's attention focused on this change that's needed?
The focal point may be only mental between us as individuals. It may not affect the sun itself, but I wouldn't rule it out. However, quite a few people who probably had that experience that they thought of a certain person, oops, and all of a sudden they meet one. They haven't met it for years and years and years. So there's an interconnection with it. For example, I was in one of my novels when I was writing, I needed some information on the pyramids in Egypt. And as I was working on that, the phone rang and a fellow called me from Jordan, from all places, somebody that I had met in Seattle. He called me, we started to chat, and I said, I'm looking for information on the pyramids. He said, oh yes, I lived in Egypt for a while. I can tell you all about it. Well, how is this possible that somebody calls from Jordan at the very time on a subject that I was working on? These coincidences do happen, and there's a lot more that we don't know. We think we know so much, but I think there's a lot more that we don't know than we do know. But that brings me back to that critical question: how can we trust ourselves with what we do know? Do we know enough that we can move the world with it? Or are we so small-minded that we bicker over little points that prevent us from responding to the big challenges?
Yeah, Rolf, I wanted to chime in with this. When you're talking about the cooling in the northern latitudes, Alberta and Canada with the tar sands production, everybody just takes that as tomorrow there's going to be just as much oil coming out of there. What happens if that area freezes over? What happens if areas that are in, say, 60 degrees north latitude and above suddenly go offline for oil production? I mean, how's this going to affect us? And is there any other energy substitution? I don't know, you're talking about plasma current drive. Can we invent something like this and get everybody thinking to that focal point of, we need to survive this. We need to all start working together, new energy sources, and, maybe that's the focal point.
Mm-hmm. We have to work together to survive this. And whether we get into an ice age or not, we're running out of fossil fuels. The best estimate is that we have about 60 years left. We only have about 60 years of nuclear fuel left at the current technology base in nuclear power production. So this stuff is running out. Whether the tar sands freeze over, which they will most likely do, we better have an alternative ready. And we do need that alternative already now to do the preparations, to build the infrastructures that we need to relocate all of humanity away from the endangered zones. So the only energy resource that is not a depletable fuel isn't on the planet Earth. It comes from outside the Earth. It's located in the area, in the ionosphere, and I think the ionosphere only acts as an interface to interstellar plasma. Once we have the technology developed to utilize this resource, then we don't have an energy problem anymore, because it's always self-renewing, and it's like it's enormous in scale. If it's so enormous that it powers the sun, and there's a lot of stuff out there. Once we're able to develop how to interface with that, then we have no energy crisis, and we better do that before the ice age starts, because then we will be too busy doing scurrying around other things, and besides, we probably won't have the energy that we need to survive anyway. So I would say this is another factor that we need to work on right away. You mentioned once Tesla had a faint idea that there is something out there connecting with the ionosphere. Well, he was a pioneer in that. He may not have known everything, and we don't even know everything today. But he was looking in the correct direction, and we, as scientifically advanced people, close our minds to it completely. That we need to overcome, the small-minded thinking.
Yeah, I agree. You know, Tesla had some brilliant ideas, and I really feel that solar power is the way to go, but I don't think we're going about it the right way. That we don't want to capture it through photonic means in the solar cells, but rather through induction in these frequencies, as Tesla was showing. There's a circuit between the Earth's ionosphere and the sun. For us to become a Type 4 civilization, we have to learn how to tap that current. It doesn't require putting anything in space. Tesla had the closest design to make this coupling connection. You have to place the tower over an aquifer where negative ions are allowed to flow upward freely to make that conduit's connection. It pulses energy into the ionosphere, which creates a conduit for that energy to come back down. And a few of these towers set up around the globe would provide wireless power through a simple system of a ground rod into the ground, because the current's actually traveling through the ground. He's pulling in the current through the tower, through the ionosphere, and then he puts it out through the ground. And in that transmission, there's zero attenuation, and you can attach communication signals to it. A much more efficient way than broadcasting Wi-Fi hertz through the air like we do now, which is high-powered frequency that's very wasteful and damaging to the environment, causing RF pollution.
Mm-hmm.
Tesla's system was much more efficient, and I believe if it is re-engineered and developed, that Tesla's Wardenclyffe design could lead us into a Type 4 civilization by using and harnessing the power of the sun. 1 hour of proper, the amount that sunlight that hits the earth in 1 hour is enough to power the entire global circuit for a year. That's just photonic. I mean, think about induction.
Mm-hmm. Yeah, induction, that's it's a broad term, and there's probably many ways of doing it. And Tesla just opened the gateway a bit, because that's all we really got. We haven't got enough left burning coal and gas, and we shouldn't be burning it anyway. They got much better uses than to be burned in automobiles.
Yeah, I agree. Most of those natural resources need to stay in the ground. They help balance the polarity of different regions. We see magnetic maps that are associated with where this oil is. It's key components, I believe, to building the magnetic field These elements influence the strength of the field. And I think the more of these elements we take out of the ground, the more it affects the earth itself and the field strength. So we keep pulling this oil out. You know, something I found fascinating, you know, most of the oil rig or wells in Texas were completely dry. And after the Gulf oil spill, it pushed oil from that region into Texas and refilled all those oil wells. Now, what was once empty is full again. And it makes me question, is this a finite resource or is this a renewable resource? Is anything green that burns like wood would produce crude oil? I cannot see this as a finite process.
Well, carbon is one of the highly abundant elements in the solar system and probably also in the universe. And it has been theorized by people that I've talked to that there may be a biological process or a bacteriological process that turns actual carbon deposits into liquid oil. So there may be a possibility that we're looking at a renewable source in terms that there is a process that constantly creates the stuff, which in turn probably also feeds on another resource that can diminish. But I don't think we should be even looking at oil production. We should be looking at the cosmic power production because oil is too feeble, much too feeble for our need for the future to power, would say, artificial agriculture, indoor agriculture, to power society that's stretched out between the continents. We need to have enough energy to get water out of the sea. Water is one of the big problems during an ice age environment because if there's a high degree of cosmic ray flux, there is also a high degree of drought condition because the clouds rain out before they reach deep into the continents. That's why we see a lot of drought happening. In the same time, we see a lot of flooding happening. It has been theorized by archaeology that during the deep ice ages, much of Africa was a desert because of insufficient rain. There was a time when we, as humanity, had dwindled just a few hundred. So these were kind of harsh living conditions. But with enough energy, with high density energy that we need, then we can do all kinds of things. We can melt basalt and then build bridges across the continents with it. We can melt basalt and build automatically produced, or also modularly produced housing in automated processes. We can give them away for free. Housing production is one of the big things that we need to consider. If we have in 30 years a new ice age starting in which, well, Canada, Russia, Europe, part of Asia has to be vacated into the tropics, you want to have new cities built for them to move to. How can you build enough housing for 6 billion people, let's say, in 30 years? The only way you can do that is with automated industrial processes using high energy processes for melting basalt, because basalt is the best building material we have, and it's unused on the ground. It all needs energy to melt it and to reform it into anything we want to make with it. And that energy is available in cosmic space, right around the Earth. So once we get our own minds to it, to get it, then the science will come up with a way of actually producing the link and to make it practical for us. But if science says, oh, there is no plasma out there, and there's a lot of people that are saying that, why would you even bother considering it? So people lay themselves down and say, well, we have 30 years. I won't be around anymore after 30 years when we're running out of oil and gas.
Rolf, can I ask you to take a step back and explain the basalt? For a lot of viewers out there, they're not unfamiliar with what you're talking about. Could you explain the process of the melting temperatures of basalt, how it can be formed into preformed molds, and how it can be used as building materials to implement this strategy you have on the equatorial bands for indoor farming?
Mm-hmm. Well, basalt is a finely grained stone that is basically lava, and it's light and very strong. It's being used presently in very small quantities. It's used in rebars for concrete construction. When you use basalt rebars, you get 9 times as much strength out of them per weight than out of steel. Now basalt melts at 1400 degrees. So it also, its specific heat is it's twice as much as steel. So you need twice as much of energy to melt it than it would take to melt it with steel. So it makes it a bit impractical to do it with gas and oil fired or whatever processes they use it for. But it's being used, it's being manufactured. They're making floor tiles out of it. They're making auto parts out of it. They're making pipes out of it, especially pipes that need to be resistive to chemicals and high temperature and abrasive substances. So basalt is being used. They also extrude it into microfibers. And it's the best insulator that we know. It's 3 times more efficient as an insulator than asbestos is. Now, why I focus on basalt is because there's almost an infinite amount available sitting on the surface, ready to be used. You don't have to pre-process it like in steel production. It's a long process to make steel out of ore. The basalt is sitting ready, process ready on the ground. All you have to do is break it up and melt it. We have forgotten how the figures, a huge amount sitting in the Columbia River on the United States, in that area, the Columbia River flat basalt basin, somewhere around 150,000 cubic kilometers. And we have twice as much sitting in India in the Deccan traps, what they're called. And Russia has about far more than that in the Siberian traps. So there's more basalt sitting ready on the ground than you can possibly ever use. You could fill the entire landmass of the Earth more than 50 feet deep with it and still not run out. So that we have this building material readily available. All we need is energy to use it. Now, once you start building or floating infrastructures like floating gardens for growing wheat. That doesn't really take a lot of material to produce this. Assume you have a shoebox, or you take a shoebox, take a lid off. Well, the lid fits tightly over top of it. Now, put the shoebox on water, it floats. And if you put a lid over top of it, then you can put your garden on it. Now, there's a certain amount of weight that presses down against the shoebox would sink. But if you put pressure onto it, like pump it up with your tire, you can create a floating platform with very thin materials. You don't need steel platforms. You just need a very small, very thin, maybe an inch thick, a kilometer wide, just held up by air pressure. So you can make floating agricultural modules quite easily on this basis, with having like a shoebox pumped up, sitting in the water, and with overlapping edges, made out of basalt. Does that answer your question?
It does, yeah. And how do we get people to come past this modern society thinking of money and commerce and economy and earning wages and saving money? As we progress into this area where food production gets lost in some areas and we need to quickly scurry and find ways to make up for lost production, credit's going to be hindered, economic collapse is going to ensue. There's just a lot of things with our modern last 70, 80 years of being ingrained in our mind of this is the way the world functions. There's no other way it can function at all. So how do we break out of this? There's no other possible way into this new paradigm, literally, where we're going to have to evolve with either a new type of currency, which I believe is going to be the thought and the knowledge for you to help others. I think that's going to be the new currency, your knowledge on being able to implement systems or help put systems together to help people survive. That'll be new currency. But how do we really get away from this? Everything's bought and paid for. $1 equals $1, or 1 yen or 1 yuan, whatever it might be. How do we go away from that and get people focusing on something else?
We once did that. The very thing. Before the United States was formed, there was a colony in Massachusetts called the Massachusetts Commonwealth, I believe. And there was an agricultural society, and credit was almost impossible to get for building steel works. They needed steel implements for agriculture, machinery and stuff like that. So they said, well, if we can't get the money from the king to build our steel mill, or steel works, our iron works, we just make our own money. So they set up a scrip system. And so they said, what we're building is going to make our lives better. Whoever subscribes to it and helps build this ironworks gets a scrip, and the scrip becomes valuable by the products that are being created. And that actually really took off. That became the basis became the basis of the American Revolution. That scrip system made everybody wealthy. It not only created the best ironworks in the world at that time, but everybody had money. The scrip became money, and they traded with it, and they bought goods with it, until the king said, well, we can't have it that a society lives outside the king's money bags. So they caused them to actually scrap this. One part of it was the pine tree shilling way back then. So they scrapped it all, but it wasn't forgotten. That it enriched, that enabled people to work together to produce what they need. And I believe out of that came the American Revolution. The Masons were part of that crowd, of the Massachusetts crowd that were involved with that ironworks thing. So that was an idea to get away from the money bags. Now we will always need to have a way of equitable contribution. But once you can demonstrate to society that the products that you produce will everybody make so beneficial to everybody that we don't even need money. If you can produce food with such ease that you can give it away, why would you need money? I would say we probably can get into this infrastructure building by saying to society, do you really want to live in a condition where 3/4 of your income goes for rent or for mortgage payments, and the rest doesn't even pay you enough for food and much less for health care? If you say to these people, come to us, help us build these agricultural infrastructures, and we'll give you free housing, we'll give you all the food you can ever want, we'll probably give you a few stipends that you can trade with each other to buy furniture or to buy whatever artwork that they produce to make each other rich. But it has to be away from the money syndrome that we are trapped into right now. Besides, apart from that, the dollar is kind of worthless anyway. A currency gets its value from what is produced. And in the United States, the production is really not there anymore to support the supposed value that everybody puts on the American dollar. It's kind of an empty currency. Yeah.
Yeah, that's true. We're going to have to get away from this central bank type of printing environment that we're in. But as soon as you want to step away from that, all of their minions come out and try to dissuade you, either through words or through military action, to get you not to move over to that system. But when we go into this time when there's absolute upheaval across the planet due to increased earthquake activity that will destroy infrastructure that can't be repaired quickly enough until it's destroyed again by another earthquake or a flood or something, and then we come back into the food delivery system when it won't be delivered on time. A, the lack of credit, and B, just the mixed up growing seasons. At some point, something's going to have to roll over where, you know, you were both talking about earlier, can a focal point of all human consciousness at the same time on a single issue in a single day, can that actually morph and change physical reality? And at that point, can we kick the central banks out? And is that what they're really afraid of, is all humanity getting together in a single instance and literally changing the construct of our environment around us?
Well, to a degree, that already happened in the 1930s with the Glass-Steagall Act in the United States, where Roosevelt said to the banks, you will not use your depositors' money to invest in the speculative investment. They separated the commercial banking from speculative banking. And having a secure banking system actually developed. The United States, they made credit available for building industries and so forth. And that probably was the basis that saved the United States during World War II. It enabled the industries to be built up. After World War II, they started needling away to get away from that protection of the banking system. And they all wanted the depositors' money. Then we had the crisis with the savings and loan institutions and so forth. And then eventually in 1999, I believe it was, they repealed the Glass-Steagall Act. Now every bank can take the depositors' money and gamble with it in the most high-risk markets. Because if they lose it, it's not their money, it's the depositors' money. And then they come to the government and says, well, if you let us go under, then the whole system will go dead. So you have to bail us out. That's a swindle. But there is a lot of pressure right now to reinstate Glass-Steagall. Now, that may be just a small step, but that comes from Trump, that comes from many congressmen, that comes from society itself. There is a groundswell to get back to something reasonable. But as a first step, I'm saying, once you make that first step, then probably somebody will say, oh, there's a second step that we need to do, and a third step that we need to do. And I think we're in a position that the movement has begun, where we can say there is a movement happening.
Yeah, I think that's all with 9/11. The focal point of 9/11 was kind of the touching of the monolith or the movie screen. And in that, we see that our reality is very scripted. Everything around us that takes place is very scripted. And we're awakening to that now and seeing it for what it is. And that focal point was very powerful in the human conscious to awake to this false news, the false propaganda. We see it playing out now real clearly in the news. Can't trust mainstream media. Now mainstream media is throwing stones at the, YouTubers, the other non-mainstream media sources. It's a battle. You can't even talk about the weather without starting an argument with somebody. I mean, they've got their point of view and beliefs. We can't really communicate with anybody civilly and have civil conversations to even come to these conclusions. And I think that's the attack we're seeing, is this division through anger, and people become very, afraid. And that fear is leading to the anger and this acting out of that I have to do something, I have to do something. And in reality, I don't think, we need to do anything. We need to really observe what's happening, watch the changes, and prepare for these changes as they come. We have to adapt, like David says. These changes are going to force us to adapt if we ignore them.
Well, we can move ourselves to become more alert and more receptive to the changes that are necessary. And I think people are sensitive to that too. They're not as dumb. Look at the global warming hoax. It started in 1974 when the scientific community said, well, we need to think about the coming ice age, what preparations we need to do. And to counter that, the global warming scam was invented and was promoted and promoted and promoted. And there were a lot of scientists around the world that protested against it. We had the Leipzig Declaration, the Heidelberg Declaration, all kinds of. I think the Heidelberg Declaration brought together 5,000 scientists from around the world protesting against this nonsense assumption of man-made global warming. But it wasn't heard. It didn't even come to the climate conference. It was never even mentioned. And they had the Oregon petition. They brought together signatures from 27,000 scientists worldwide protesting against the false assumptions. Now, what do we see now? We're quite a few years down the line. Well, the Secretary of the United Nations on Climate Change has publicly stated that climate change has nothing to do with climate. It has to do with economic policy. We have to change the economic policy to prevent economic development in the world, because economic development is bad. It causes too many people to grow. We need depopulation and so forth. That was publicly stated, that the global warming thing was a scam, was stated by the very people that have promoted it. And I believe just 2 days ago, NOAA, the National Oceanic and Atmospheric Administration, they publicly stated that all the statistics that supposedly have supported the man-made global warming thing were simply faked. Now these things coming out, and they will probably cause a lot of people to think. Now, mind you, it's not too many people that know about it, and you probably won't read it in the newspapers. But that movement is on, and it is a movement in thought, and that can have tremendous effects that can change the whole scientific environment. When people recognize the science as lying to them intentionally, that's something that people don't really take easily. People don't like to be lied to, especially not from people that you trust. The scientific community had always been trusted in society, and now they become revealed as liars. I think that overturning will do a lot to clear the field, start more honest thinking, more open-minded thinking, and more scientific thinking. What do you think?
Yeah, definitely. I think Trump has, if given the time, here, he has great potential to make some changes. I like the things that he's saying, and I really think it's important that we get back to playing by the rules. And the rules involve consent. And a lot of these things are not consented by the American people, like paying for forced taxes on this health insurance and vehicle insurance and license and all this stuff that we don't give our consent to. It's highway robbery. It's almost like rape. And we need to get back to the Constitution of playing the game by the rules. I mean, if this was a game of rugby and we consent to, beating each other up on the field because it's the game, hey, we consent to that. But we didn't consent to this type of abuse from our government, and they have taken advantage of their authority in that they make these things happen because we have no choice. The only choice is suffer or do what you're told. And that's got to change. Let's get back to freedom and consent.
Yeah, and could I add something in there, Rolf? You touched on that. My video yesterday was full in depth about the NOAA controversy and the scandal that came out. Now, one thing I noticed right away doing the Google search and looking for links to the story, all the alternative media had it. Everywhere from Breitbart to Judith Curry, No Trick Zone, What's Up With That, Robert Felix's site, iceagenow.info. All these sites carried that story. But you know what was absent? BBC, CNN, ABC, NBC, nowhere to be found. Couldn't find any links anywhere. Al Jazeera, nothing. AP, didn't hear it. But all the other alternative links did. You know, Fox picked it up eventually, and Wall Street Journal did. Yahoo News picked it up, but otherwise totally silent. So, I mean, we're the majority of people getting their information these days. And how big is that message? This is the biggest climate scandal, at least in the last decade, beyond what happened with ClimateGate. But nobody's, I mean, that's at least 50% of the people on the planet that are not going to see that there was such a scandal. That proves global warming does not exist anymore. It never had. It's been a scam since the beginning. Mm-hmm. This is the biggest news story literally of the decade.
Yeah, and you're right. But people picked it up and they know it, and it percolates it. And there's also a side story to that. Fox actually carried it, yes, you mentioned it. And a lot of the other media, they're losing business. And not over this particular issue, because they also print all kinds of lies against Trump and all that rhetoric. And the people get fed up with being lied to it, and that's reflected in their revenue. Some of the people of the big chain newspapers, they're losing their revenue, and they have to change. So it's what people think. It actually does have an effect. And it may be the reason why those things came out in the first place. Probably 10 years ago, these people that knew that were too scared to say so.
Yeah, and I had an add-in question here from Tony, as well, from Suspicious Observers. He's asking me to ask you, Rolf, what the cyclical magnetic wandering during the 1600s grand solar minimum and the Maunder minimum, the magnetic pole was not moving as it is today. It's quite different, the circumstances in the magnetic progression of the pole, the way it's moving 40 miles per year, and then it's now a little bit above that to 55 miles per year now, going toward Kamchatka, Russia. How do you see the difference in what occurred in the 1600s with the differences in actually the entire primer field collapsing and the magnetic pole on our Earth moving, and we're going into a grand solar minimum induced, and then even heavier cooling that you lead into?
Yeah, I looked at that, and that's an indication that the solar system is weakening. If you have, we look at our sun, our planet. Our planet is on a spin axis that is inclined by 23 degrees. And the Earth is on the ecliptic between two primer fields that feed into the sun. These primer fields have a magnetic field. They both produce a magnetic field with a counterpolarity that comes together around the plane of the ecliptic. Now you have the magnetic fields that go perpendicular to the ecliptic. Now the Earth is inclined by 23 degrees. So if the Earth's magnetic field is much stronger than that interfering magnetic field from the primer fields, then the magnetic field is inclined with by 23 degrees. Or how shall I say that? The primer fields pull the magnetic field away from the spin axis. now that the magnetic fields of the primal fields are getting weaker, that deflection becomes less and less and less, and it's moving towards the poles, towards the geographic pole, towards the spin axis, because without external fields, the spin axis should be the magnetic pole. And it used to be 23 degrees off in 1830, and between 1830 and now, it's moved almost back to the pole. That shows how weak the solar system has become by weaker magnetic fields coming from the primal fields that deflects the magnetic field of the Earth away from its spin axis orientation. Does it make any sense? I tried to.
Yeah, Trevor, go with that. When you were talking about some of the same things, you want to hit on that?
Yeah, it's all really good points that Rolf makes. I can't disagree with anything he said there. I mean, it's it's important to take a look at the primer fields and his work there. Even Wal Thornhill recommends that people take a look at the primer field videos. I think it gives us a better understanding of how these impinging forces work and the field strength. That makes sense with what Rolf's saying. The weakening field is going to shift that field. And we may be in for a magnetic flip with this one. So it may be more significant than just a mini ice age. It looks like accumulation of multiple events are taking place at one time. And we have instability and volcanic activity as well. Korea just recently announced activity in a supervolcano region that's showing a lot of activity of asked the United States for assistance. And Yellowstone continues to act up too. So my concern here with the weakening sun and the fields is the electrical stress fracturing that may result in the form of an earthquake or a potential volcano that could lead us into some kind of fallout situation with a nuclear type winter. We're seeing a lot of cloud production, not only from cosmic rays, but also the cooling effect of all this pyroplasmic dust in the air from the volcanoes exploding. So are we looking at a type of event that's the sun acting as a collector, capacitor, this energy in its weakening state is eventually going to release what it has in the form of a massive super flare that may cause some potential electrical stress fracturing, or just the lack of output may cause an electric stress fracturing event as well. I'm not sure. What do you think, Rolf?
I think there is too little understood to make any prediction of how many more earthquakes we're going to get and when. But we do know that we do get earthquakes a lot. And now that the sun is in a state of change, we should be able to expect, we should expect more earthquakes, an increase in earthquake activity. But that's really hypothetical, because we don't really don't react to it. We say there's a possibility that more earthquakes will happen, and there's definitely a possibility on the West Coast. We have this San Andreas fault that hasn't moved for a very long time. There's probably built a lot of stress up there too. And when that goes, it causes a lot of damage. But are we saying, well, maybe we should consider moving away from the Earth, putting some sensitive stuff on the sea? Sure, the sea has some tidal waves and so forth, but for floating installations, these can be mitigated. whereas big construction and installations on ground, if you have a big earthquake, they can't really be protected. So you're having a possibility that the Ice Age startup also will cause a lot of earthquake damage. And that's just another reason for moving some of that population centers onto the sea in floating platforms. Yeah. Another reason for putting agriculture afloat on the platform onto the seas is the water is right there. Agriculture needs water, and when the water is scarce in the atmosphere, well, you get desalination out of the ground. Right now, the only desalination that we're doing is with nuclear power. But we don't really need to do that. Around the equator, we have very deep seas, say about 5,000 feet. No, pardon me, 5,000 meters deep. Most of the salt water is fairly homogeneous, and salt water is 20% heavier, no, pardon me, 2% heavier than fresh water. If you use that differential between salt water being heavier and fresh water being lighter, you can actually cause desalination to happen almost by itself. You have fresh water flowing out of the ocean. If you put the separation barrier 5,000 meters deep into the ocean, and it doesn't take a great deal of infrastructures to do that. It doesn't even take a great deal of energy to drive the thing. And if you put it in the middle of the equatorial belt between the continents, you can feed your agriculture quite reliably with desalination systems, because you wouldn't get any reliable water anyway once you get into ice age conditions where you really don't know what's up and what's down. So you want to be able to have reliable water for your agriculture, and desalination through deep ocean desalination will probably fit the bill.
Well, it sounds like you need to be talking to Elon Musk and some other investors get you into venue on the Joe Rogan show to reach millions of people with your message, let people come back, come to you, find you to talk to you about your message of hope to move our agriculture, this new reindustrialization of our new agriculture that we're going to need to move to during this cooling period. I talk about it on my channel. We always need to work together, and we're going to have to move and reinvent everything in our lives here. You already have a solution. People should be talking to you first and foremost, because you already have a solution, a plan, a blueprint for solving this problem.
Well, I worked for many years on that. And it takes an incredible amount of time to do a single video. For 2-hour video, it probably takes somewhere in the order of 2-3 months. And my voice isn't the greatest, so I had a lot of trouble with voice over on the videos. So what you're seeing there on YouTube is the work of many years.
Yeah, I know what it is to make these videos. It takes a little bit longer. So, each minute you see on the screen when you're watching a video, it takes hours of production, depending how good, how fast, how much info you want to put into it, how in depth. It's not just, we sit here and we throw a bunch of slides in and we talk and we're done in 15 minutes. That's completely not the way it goes.
Rolf, do you have any?
Yeah. Do you have a last message for anybody right now? Anything that you want to tell anybody that can convey your message? Because that's really the reason I wanted you to talk today, was to try to get your message out to people. Not really about myself. I don't care about that. I wanted you to spread your message to others. And that's the focal point of this interview and conversation right here about the mini ice age and the ice age. Any last closing thoughts you want to share with people?
Yeah. Have we ever been in a movie? Sat through a movie, and at the end you get the credits, and you get reams and reams and reams and reams of names floating by, of all the people that had work done on the movie. Well, on my movies, there is one man, one name. I do it all myself. And so we need to work together to make the knowledge that has been developed more accessible. We don't need a cost of 1,000, but we do need to work together. And maybe perhaps when we work together, and a network will spring into action that will change the world. Like a blockbuster.
Yeah, that's a good way to think. Trevor, you got any ideas to throw off as we're closing out here?
I think in closing, I just want to thank Rolf for all the years he's put into the videos, because it really helped me to come to a lot of the conclusions that I've drawn. And there's a lot of good information there. If you're not familiar with Rolf's videos, definitely spend some time on his channel. Make some very good points. And the point of working together is happening right now as we speak, having these conversations and this going out to other people's ears to listen. There's an entire movement of observers that have this in their focus, you know, to pull this movie screen aside, the script that we're seeing, to be suspicious of everything and really question everything that's going on around us. And let's start coalescing our ideas and concepts, bringing this to fruition, and protecting ourselves in the long run, and protecting humanity from the potentials of disaster that are always present. The earth in the long run is a very dangerous place to live. There's always natural catastrophes that are potential extinction level events, but time after time, we've overcome them and we've survived, and we're still here.
Trevor, on your show, one thing that always I love to hear is when you close out your show, you say, be safe. You're concerned for humanity. Be safe. That's
yeah. Ben closes out all his shows that way every morning. You know, eyes open, no fear. Be safe, and it's kind of the moment.
I really love that.
All right, well, I'll link everything below so you can definitely take a look at Rolf's work. Remember, his YouTube channel is Ice Age of the Dimming Sun in 30 Years. I will link everything below, the website, Ice Age Ahead, IAA.ca. Make sure you can get back and find all of his videos. His website's an amazing treasure trove of info as well. Just start right there. You can dig in, and you will be busy for months after you watch everything that's in there. And I get a lot of you asking me, how did I get into this? Well, Rolf was a huge influence on me as well. As I watched his videos, I was getting ideas, comments, and, you know, as I was doing my timeline out, he was a heavy influence on how I see the progression just in these short amount of years going into the 2023, 2024 coolest period. So that's to answer some of your questions of who were some of the influencers on my thoughts.
Thank you, David.
He's one of them. You can definitely learn from him. Anyway, I encourage you all to do your own research as well every time. And this is going to be a golden age for us in the humanity kind of timeline over the last few 100,000 years. This could be it. This could really be the apex and the golden age of us, of everything we've learned, the ascension that we have, the spirituality, the connectiveness. If we all work together and these old systems fall away and they're regenerated with new systems that help us expand and evolve even further. I'm totally hopeful during this time, coming at you with the message that I wanted to share. And here's others that are at the top level that have the same positive, hopeful message for us on the planet.
Thank you, David. That's music to my ears.
Yeah, thanks.
All right, well, I'll sign off with that, and I'll make sure that we post this as many places as we can here. And Rolf, I'll talk to you later. And Trevor, thanks for joining us tonight.
We had a successful meeting here.
Yeah, thanks, David. You did a great job.